For the panel data model, the composite error term has two parts: the individual specific effect alpha and the idiosyncratic error term epsilon. The individual specific effect alpha is independent and identically distributed with mean alpha and variance sigma alpha square, while the idiosyncratic error term epsilon has zero mean and variance sigma epsilon squared. It can be proved that the correlation within individual over time is equal to the formula shown in the textbook. In question 6, we calculate this correlation rho manually. First, we use the XTRAD and the random effect option to run the random effect panel data model. The output gives the estimate for rho and for theta. We can use the standard deviation of the individual effect and the standard deviation of the idiosyncratic term to calculate rho. We use e-return list to take a look how Stata stores those values. Then we use the formula in the textbook to calculate rho, the fraction of variance due to the individual effect. It's exactly the same as that in the output of the random effect model. The random effect estimator can be obtained by OLS estimation in the transform model like this, where theta can be calculated using this formula. When theta approaches 0, it's the pool OLS estimator. When theta approaches 1, it's the fixed effect within estimator. We can also calculate theta using this formula. And it is identical to that from the output of the random effect model when we are using the theta option. Question 7 is about the unbalanced panel data. We run the STRAD with option fixed effect using the balance data first and store the result using estimate store command. Then we follow the instruction in the question to randomly drop 20% of the individual year observations. We use XT-describe to take a look at the structure of the data. We have missing observation for some individuals. We see that the median period of time is 6. We can also see the pattern of the missing observations. The command XT-sum provides the information of the between variation and within variation. ID is time invariant, so its within variation is 0. The variable t is individual invariant for balanced panel data, but here in the unbalanced panel data, t is no longer individual invariant. That's why its between variation is not 0. The variable education does not change over time, so its within variation is 0. To take a look at the variable self, its between variation is larger, much larger than the within variation, which means the variable self does not change much within individual over time. This can be seen using the command xt_tab. The between summary indicates that 72% of the individuals had lived outside the South at least once, and 30% of the individuals have lived in the South at least once. That is to say, about 2% of the individuals live in the South some of the time and not in the South some of the time, and hence are doubled counted. The within summary indicates that about 95% of the individuals always live in the South, and about 99% of the individuals always live outside the South. The command xt_chance provides transition probabilities from one period to the next. More than 99% of the observations ever in the South for one period remain in the South for the next period. Therefore, the variable South is close to time invariant. Next, we run the fixed effect model for this unbalanced panel data. We also use the estimate store to save the results and use the estimate table to compare the results from different models. If we use the option SE, then the standard errors instead of t statistics will be inside the parentheses. Both the estimates and the standard errors are very close. Thank you very much for watching this video. Bye.